Okay, hey everybody.
Hey there, I'm Ashkahn.
It's Graham Slam over here.
It's not your legal name.
Well, not legally, no.
Okay.
Trying not to do anything legally. So today's question for you is, what are some things to be careful about installing a float tank when I'm worried about soundproofing?
Okay.
So, I guess, this is like a broad question in the sense there's a lot of soundproofing that goes into the room itself as well, right? And just like your basic float center construction.
Which is, that's a big
This
would be like
topic.
a 3-hour episode if we were just to talk about soundproofing.
So maybe just talk about, assume that the soundproofing is done correctly for the room and just talk about not messing it up when you're putting the tank in here now.
When you put the actual float tank in.
Yeah, definitely.
So basically, you just don't want your float tank you want to kind of isolate your float tank as much as possible from the room. You've done a lot of good soundproofing with your walls and things like that, but you can do an additional layer with the float tank itself.
Yeah, ideally your float tank would be hovering in midair.
Right.
In the center of your room, not touching anything, right? That's like the ideal setup.
In a vacuum, that would be perfect.
Oh, man, yeah. And getting there, you'd have to put on the weird float tank spacesuit kind of thing. And
But that's not going to happen, at least for another few years. So
another 6 months or so, yeah.
So what do you do? What do you do about putting your float tank into the room? Well, basically, the kind of like soundproofing term for what you're trying to avoid here is short circuiting.
Yep, like the old movie with Johnny Five, if you were alive in the 80s, I guess.
And so basically the idea is a short circuit in soundproofing is any place where you've done all this soundproofing, but you've allowed like a very easy spot for as a point of weakness, kind of in any sort of soundproof system. And what happens is sound just travels really well through that point of weakness. It's like having a bucket with a small hole in it. Like it's not a very effective bucket anymore because it has a small hole in it. That's kind of the same concept when it comes to sound.
Yeah, and this applies largely to vibrational sound when you're talking about installing the float tank. So most tanks don't do the best job themselves of keeping out airborne sound. If there's loud talking making it into the room that your float tank is in, it's then kind of hard for you to beef up the soundproofing on your tank itself to block that airborne noise. And fortunately for us, just putting your ears below the water often does a pretty good job of blocking out airborne noise.
Yeah, it's probably the biggest thing that the float tank is doing is just having water in it that your ears are below.
Yeah, so super, super helpful there. And so when we're talking about short circuiting, especially with float tank installation, we're talking a lot about vibrational noise going through. And that's where we want to make sure that there's as few just rigid, solid connections between the float tank and the walls or the floors or the ceiling or anything else around them as possible.
So one thing to do is not to put your float tank touching the wall. Especially if you have like a pod or something like that, which is meant to kind of stand somewhere in the room. Make sure it's scooted off the wall by a couple inches so that you don't have that actual connection being made.
And this gets especially, I guess, tricky or important to keep in mind when you're doing full cabin-style room setups, especially ones that are actually built into the room rather than being pre-manufactured and placed inside a room. And it means that you're really going to try to make sure that your tank in every direction is not actually touching the floor, walls, or ceiling, or anything like that. So even your studs that you're building around the tank are hopefully attached to the tank, but not touching the floor or ceiling. If you're doing, like panels on the outside of a float tank. And I'm thinking of our ocean float rooms here.
Yeah, and so basically the difficult thing comes with waterproofing. Because with waterproofing, you don't want there to be random holes and stuff like that. And with soundproofing, you do. So you just have to be kind of careful. Sometimes, depending on how your room is set up, you just find that right balance. Like you make sure the panels themselves are not really touching anything, and you kind of connect it just with a line of caulking. And that way, that's kind of a less rigid material that's actually connecting the float tank to the wall. Or if you have an edge that's actually not somewhere that is right next to a shower or super exposed to water or something like that, actually leaving a gap there, not having any physical connection with the wall panel and the wall that it's next to.
Yeah, and so this gets interesting because from the outside looking at it, it can look like it's just a straight solid surface. For example, in our rooms with the ocean float rooms, the wall comes straight to the wall of the float room, goes straight to the wall of the room, but stops about a quarter inch short. And then we caulk in that quarter inch gap with some white caulking that kind of hides that line. But visually, for a customer or for anyone looking at it, it looks as though the wall of the float tank is butted right up to the wall of our room. So a little deceptive. But if you let that wall touch the other wall, the wall of the tank touch the wall of the room, all of a sudden any vibrational noise going through the interior of your float room is going to pass right into your float tank, and from there right into the water and into people's ears. So that's why this rigid connection gets really dangerous as far as soundproofing, and why it's called a short circuit, is you build this big, complicated, beautiful soundproofing system, then one little rigid connection, and the vibration will just find its way in.
And as you can imagine, the most difficult part of this is where the float tank touches the floor.
Because you can't just leave a gap there.
Yeah, at least for a few years until we have that sort of technology.
Yeah, a few months.
But so, the float tank has to sit on the floor. And so what you do here is you can create things to go between the floor and the float tank that are specifically designed to lower vibrational noise. The most common thing people use are vibration isolation pads. They're kind of just these pucks of various of material, like varying density material, like layers of either rubber and steel or rubber and like EVA plastics and different things like that, or sometimes cork. And they get fancier too. You can get like spring-loaded ones or ones that are a lot more expensive. You have to be a little bit careful because some of the nicer, fancier ones are really specifically meant to isolate a certain frequency of vibration. Mm-hmm. So they're more kind of, the often reason these things are made is because they're meant to go underneath equipment that vibrates a lot. So it's kind of like the opposite is what the purpose of these usually are. It's like you have this piece of equipment that's making all these vibrations. HVAC, big air conditioners on ceilings is kind of what these with the vibration isolation
shoe
kind
sewing
of pads.
machines, yeah, whatever it is.
And you put them on top of these isolators, and you get them specifically for the frequency of vibration these machinery is doing, and that stops that machine from vibrating the rest of your building. And we're essentially trying to do the opposite. We're trying to get vibrations from everything else to not go into a piece of machinery. And the difficult thing there is, we're trying to isolate all sorts of vibrations, car noises going on, like random things from our neighbor, all sorts of different stuff. So it's hard to have this one specific frequency range that we're trying to deal with. So, things that go under HVAC equipment tend to be a little bit more generic. Some of them are still even fancier, but still kind of generic. But a lot of ones are made specifically for a very identifiable kind of range of vibration.
Yeah, and the basic thing going on here is to stop vibration, ideally, again, you have an air gap there where it's not touching at all. But if you can't, then getting as close to an air gap as possible is really nice. So that's why we only have these kind of 11 pads under our float tanks with 11 points of about 3-inch by 3-inch contact. So there's not just a giant sheet that the float tank's sitting on right there. So we're already limiting contact with the floor. And then, like Ashkahn kind of mentioned, as sound is traveling through these different densities that go into the vibration isolation pads, or VIPs as I call them, it breaks it up. Sound doesn't like traveling through different densities. Of course, the prime example of that is just going from a physical material into air is the greatest change of density, and so that breaks up the sound wave the most. But there is still a transfer from that vibrational noise into airborne noise. And then changing densities between, again, a hard plastic and kind of a softer one, or between steel and rubber, that every time it switches between type of material, it's going to break it up a little more. So that's kind of the concept that's going on here.
Yeah, so you have that change in density, and you have just minimizing the amount of surface area is kind of both the focus of these things. I mean, even if when you look at a single pad, it's 3 inches by 3 inches, but it's got like grooves on it. Yeah. So only like 20% of it, even that 3-inch by 3-inch surface, is even touching the ground itself. So it's really kind of built to minimize as much contact area as possible. And then we take those and we put them on usually a big rigid piece of something. What we use is kind of HDPE board, a big sheet of plastic, so that because there's such few points, we don't want to damage our float tank by putting it directly onto the fiberglass and creating kind of these stress points on the fiberglass of the tank itself. So we'll attach it to kind of a big rigid board, and we'll put the whole float tank on top of that. And then we also have to do this for your entire filtration system.
So important. Yeah, it's a really easy step to miss, but so important.
Yeah, because otherwise, I mean, one, your filtration system might come built assuming it's supposed to be the same height as the float tank. So sometimes you have to do this just as out of necessity to make sure the pipes still line up. But if you've done this whole thing to your float tank and the float tank is connected to the pipes and those pipes are connected to your filtration equipment and the filtration equipment is sitting on the floor, you therefore still have that short circuit. That's the point that sound is going to most easily go in through your system. So you really want to think about isolating everything. And the nice thing about that is your pumps create a lot of vibration noise. So having the vibration isolators under your filtration equipment, which your pump is on, helps
actually
that.
doing what it should.
Yeah, it's actually doing what
the
it
actual
should.
purpose. So.
It's got a double whammy. It's preventing noise from going in, but it's also helping that pump noise not go out and get to too many of your other rooms.
Yep. And another, of course, thing to be careful of is making sure that your platforms themselves don't touch the wall. Now that you've built these vibration isolation pads into rigid platforms, your unit and your pumps are sitting on top of there. Now the platform itself can't touch the wall either, right? So you're kind of seeing this. You have to almost just logically think through it. Like you can't even go through the list of all the places you need to make sure there's no contact. But looking at your tank as you're installing it and looking at your pump equipment and the platforms and everything else around, you just kind of need to look around the entire thing mentally and make sure there isn't any place where if there's vibration coming in through the wall, ceiling, or floor, that vibration can transfer to your float tank in any way. And again, all it takes is maybe an inch-wide connection or a little point where your platform is touching that wall to ruin a ton of the investment you've made in the rest of your soundproofing. So it's really the float devil is in the float details on this one.
That phrase is going to catch on, I think.
Well, I use it all the time. It's been in at least 50 episodes so far, I think.
All right. Well, that should give you some information. If you want to learn more, we definitely recommend watching the documentary from the 80s, Short Circuit. That should fill you in on all those other float details. Yeah, if you guys have other questions, you can hop over to floattanksolutions.com/podcast.
And we will talk to you tomorrow.
Bye.